Hello everyone, welcome to the video lecture series of inverse Laplace transforms. In this video lecture we would be solving differential equations. So let us see how to solve a differential equation using Laplace transforms. Now this is our new differential equation, d square minus d minus 2 operated on y is equals to 20 times sine 2t, where the initial conditions are y of 0 is 1 and y dash of 0 is 2. Now in order to solve this differential equation, as I have already told you, you let y is equals to f of t. Thus what you have is Laplace of f of t is equals to phi of s. Okay, now consider your differential equation d square minus d minus 2 operated on y is equals to 20 times sine 2t. You can simplify this equation by writing in this manner: d square y by dt square minus dy by dt minus 2y is equals to 20 times sine 2t. Okay. After this, you operate Laplace operator on each of the terms. So when you operate Laplace operator, this is due to the linearity property, it is allowed. And so now you have seen that in my previous video lecture that Laplace of d square y by dt square is nothing but Laplace of f double dash of t, right? So you write the corresponding formula of this, that is s square into phi of s minus s times f of 0 minus f dash of 0. Okay, now put a minus sign, and then there is Laplace of dy by dt. So you put a bracket also because there is a minus sign, and then you write the formula for Laplace of dy by dt, which is same as Laplace of f dash of t, that is s into phi of s minus f of 0, and then minus 2 times Laplace of y is nothing but Laplace of Laplace of f of t, which is nothing but phi of s, right? So that is what you do over here. Now then here you have this as 20 times Laplace of sine 2t, which is nothing but 2 upon s square plus 4. Okay, I'm writing here it as 2 squared. Okay, now you substitute the value of f of 0 and f dash of 0 from the conditions over here. F of 0 would be 1 and f dash of 0 would be 2. Okay, so you substitute the values. After substituting the values, you simplify it further, carry out the simple algebra. Okay, now at this step what I have done is I have multiplied this 20 inside and written this 2 square as 4, and I have shifted this minus s and minus 1 onto the right hand side, and I have obtained it as plus 1 and plus s. Okay, that is what I have obtained here. Okay, and then what you can do is you can create a common denominator on the right hand side, and you will have to simplify it little further, and on simplification you obtain this, that is phi of s is equals to s cube plus s square plus 4s plus 44 divided by s square minus s minus 2 times s square plus 4. Now observe here that there are two quadratics in the denominator. The first quadratic s square minus s minus 2, and the other one s square plus 4. The first quadratic can be simplified little further. You can factorize it, and this one is irreducible, okay, on R. So now what we do is I'll call this by star. Okay, now I'm going to simplify this expression phi of s further using partial fractions. So what I obtain here is, this is the expression that is over here. Okay, I am writing the denominator s square minus s minus 2 in this manner. S minus 2 times s plus 1. It's the factor of this quadratic equation or quadratic polynomial. Okay. Now this is s square plus 4. I am keeping it as it is. Now since I see that this quadratic has two different roots, distinct roots, I am able to write them as a upon s minus 2 and b upon s plus 1. Okay. And then this is the quadratic which is irreducible, and since it's a quadratic, I write in the numerator cs plus d. Okay. Now I call this expression by yellow star. Okay. You can call it by capital A. This red star can be called by capital A, and this one can be called by capital B. Okay. Or you can put it a star or double star. Doesn't matter. Okay. Now, in order to solve for A, B, C and D, these constants, what you need to do is you multiply this denominator over here that you see, okay, onto the numerator of this expression. Okay, you multiply it over here. Now when you multiply to each of the terms, what happens is that this s minus 2 will get cancelled for the first term, then s plus 1 will get cancelled, and then s plus 4 will get cancelled. So in short, what you will be remaining with in numerator is a times this term, because s minus 2 has got cancelled, so these two terms would remain, and with b it would be s minus 2 times s square plus 4, because s plus 1 gets cancelled, and similarly these two terms would remain the last term. Okay. Now in order to solve this further, you will need to substitute values of s wisely. Okay, so s, if you see here, over here, if you see, if you put s equals to minus 1, then this term collapses, because s minus 1 and plus 1 becomes 0 over here also, and you will get the value for b. So that's what I am doing, and I get the value of b as minus of 8 upon 3. You have to substitute s equals to minus 1 on both the sides, okay, on LHS over here as well as the RHS. Okay, now put s equals to 2. So what you see is that this term collapses and this term also collapses. So what you remain is with the coefficient a, and you get the value as 8 upon 3. Now in order to solve for other c and d, these two coefficients, first I am going to put s equals to 0, and at the same time the value that I have found for a and b also I am going to substitute. So on substituting those, I'll get the value of d as minus 6. Similarly, put s equals to 1 and put value of a, b and d that you have found already, and then you obtain the value of c equals to 1. Okay, so having done that, you write down this expression that is in the yellow star that you see. You write down this expression over here, and these terms, a, that is 8 upon 3, b, that is minus 8 upon 3, c, that is 1, that is 1 into s is s, and d, that is minus 6, that is what I have written here. So you write down that in this yellow expression, yellow star expression, and this is, if you see, the left hand side over here is nothing but the this expression. Okay, so finally what you have obtained is phi of s is nothing but this expression. Okay, now you operate L inverse operator on both the sides. When you operate L inverse operator on the LHS, you will obtain f of t, and on right hand side, when you operate L inverse operator, the constants would come out and you will be left out with L inverse of 1 upon S minus 2. Okay, and here it would be minus 8 upon 3 is a constant, so it would come out and you will be left out with 1 upon S plus 1 inside the L inverse operator. Similarly, over here S is not a constant, it's a variable, so it remains inside. Okay, so S square plus 4 is also a variable, so that will also not come out and it will remain in, and this constant 6 minus 6 is a constant, it will come out, and what would remain is L inverse of 1 upon S square plus 4. Now if you observe here, the L inverse of 1 upon S minus 2 is nothing but e to the power 2t. Over here it is nothing but e to the power minus t, and here it is cosine of 2t. Okay, but the last term we do not have any formula coming into the picture, but if you observe the formula list, it is one of the standard formats, and it needs over here, since it's a 4 square, it's a 4, then it means it is 2 square. So what you can do is multiply and divide by 2, and this 6 gets split up into 3 into 2, and finally you obtain this as your final answer. So that is 8 by 3 into e to the power 2t minus 8 by 3 times e to the power minus t plus cosine 2t minus 3 sine 2t. Okay, that's how you will get your final answer, and that is what your y is. So this is how you solve a differential equation, and I'll leave some practice problems for you to solve. So that's it for today, and thank you.